So good morning everybody, myself Acharya Vishvendra. Let's discuss the parameters of an electron as per the Bohr's model. So we have discussed in the last video the frequency of the photon emitted. So in that case, Rydberg constant is equal to 1.0797 into 10 is to the power 7 meter inverse, which is 109678 centimeter inverse. Now if we calculate the wavelength of the photon using the relation, so after substituting, the relation comes out to be 1 by lambda is equal to rz square 1 upon nf square minus 1 upon ni square, and z is the atomic number of the atom. Now let's discuss the various graphs related to the parameters. So let's first talk about the radius of the nth state. So we know that radius is proportional to n square. So graph between r and n will be a parabola. Then if we draw a graph between r and n square, so you assume that n square is x, so r is proportional to x. So graph will be a straight line. Then if you draw the graph between r and z, so r is proportional to 1 by z. So the graph will be a rectangular hyperbola. Next is the speed of electron in nth state. So we have just derived that v is proportional to z by n. So the graph between v and z will be a straight line. Then between v and n will be rectangular hyperbola, and that of v versus n by n will again be a straight line. Then next is graph of kinetic energy. So we derived the expression that k is equal to k naught z square by n square. So from here we can say that k is proportional to z square, so graph will be a parabola. Then k will be proportional to 1 by n square, so it will be having a shape like rectangular hyperbola. Next is graph of potential energy. So potential energy is minus u naught z square by n square. If we assume that u infinity is 0, so the graph between u and z will be a parabola, and graph between u and n will be a rectangular hyperbola like this. And we can see that if n increases, then u increases, but magnitude of u decreases, as it is evident from the graph over here. Next is total energy. So total energy is minus t naught z square by n square. So if we draw graph between t and z, that will again be a parabola. Then of t versus n, rectangular hyperbola. Again the same relation is valid over here. If n increases, then t increases, but mod t decreases. Now let's discuss the line spectra of hydrogen atom. So if we observe the spectrum of hydrogen atom, you just excite that and take a hydrogen gas in a vacuum tube, excite it by electric discharges, and then observe the spectra emitted by the hydrogen atom. Then it is comprising of certain lines separated by a substantial distance, which are called the spectral lines. So basically there are 5 lines: Lyman, Balmer, Paschen, Brackett, Pfund. So the series limit corresponds to the minimum wavelength or the maximum energy or frequency. So it's gonna be 1 by r, then 4 by r, 9 by r, 16 by r, 25 by r. In terms of numerical, it is 911.6 angstrom. Then these are the numerical values possible. Then the first line wavelength. First line corresponds to the maximum wavelength or minimum energy or frequency. So these are given by 4 by 3r, 36 by 5, 144 by 7, 400 by 9, 900 by 11, and these are the corresponding numerical values for this. There is one more numerical solution to this, that 1 by r is approximately 911.6 angstrom In some books it is being taken as 912 angstrom as far approximation is concerned. Now there is another de Broglie wavelength to that of a moving electron. So according to that de Broglie concept, an electron moves as a stationary wave inside a particular orbit, and if it is in nth state, then that means it forms n lobes corresponding to the stationary wave. So we can say that 2 pi r is equal to n lambda. From there we get lambda is 2 pi n r naught by z. So in this way we can find the de Broglie wavelength of electron in a particular energy state. Then there is a concept of recoil speed of atom. Suppose an atom is at rest, it emits a certain photon. So using the law of conservation of momentum, it will recoil back, and using energy conservation we can say that momentum of the atom will be that of photon will be equal to this, and using kinetic energy and momentum relation we can find the recoil speed or the recoil kinetic energy of the particular atom. Then there is a concept of X-ray. So it is found that when fast moving electrons collides with metal surface, certain photons are emitted or electromagnetic waves are emitted, which nowadays we call as the X-ray. So if we analyze the intensity versus lambda graph for those photons, we get a curve like this. So you can see it's comprising of a peak-like structure and a continuous structure. So the peak-like structure is called a characteristic X-ray, which depends on the metal used, and the continuous spectrum is the continuous spectrum is called the continuous X-ray, which is due to collision of electrons with electrons present in atom of a particular metal, and the specific the peaks corresponds to the transition of electron from one energy state to another. If we draw graphs for various lines, then we get a graph like this. This corresponds to K series, this corresponds to L series, and we can say that if there is a energy is more or the transition energy gap is more, then we have K alpha and K beta like this, and L alpha, L beta, L gamma like this. K means suppose there are shells. So this is K shell, this is L shell, this is M shell. K shell corresponds to principle called quantum number 1, L shell to 2, M shell to 3. So K alpha means this, K beta means this, L alpha means this, and you must be knowing that corresponding to the transition of K states, energy is maximum, so its wavelength is going to be minimum. So in this way you can analyze this. Suppose we are being given two graphs, Z1 and Z2. So we can say that larger the wavelength, lesser will be the atomic number, or smaller the wavelength, more will be the atomic number. This we can analyze from the graph. Then there is a Moseley law which says that which is about the frequency of the X-ray emitted. So it says root f is Az minus b, where AB are constants which depends only on transition, not on the metal. So A is root RC 1 by NF square 1 minus 1 by NE square, and B is called a screening constant. It is 1 for K series, 7.4 for L series, and 19.2 for M series, which are experimentally determined. Now if you draw graph between root f and z, we have a graph like this, and it corresponds to zero frequency at B, and it's a straight line having angle theta, which is equal to A, which is slope of this particular graph. So in this way we have discussed atomic structures in a single video of 20 minutes, and I think it's, you can say, the summary as a whole, and it will prove to be an optimization tool in preparing for your exams. So here it's just for your competitive exams. We have escaped any derivation which are of use to the board exams. So for those you can see my separate videos on this. So I hope it works best for you. Thank you. Have a nice day.